Good morning, class. We're going to do lab 6-1 diodes. The purpose of this lab, or the objective of this lab, is to differentiate between an anode and a cathode on a diode by placing it in a circuit and by using a simple ohm meter test. We're going to skip the ohm meter test for the purposes of this lab because I've done that on the Learning Hub already. Getting into the purpose of this lab, diodes are devices which only permit the flow of current in one direction. The two leads of the diode are referred to as an anode and a cathode. For the diode to conduct current, the anode must be connected to the more positive lead and the cathode must be connected to the more negative lead of the circuit. To determine which lead is the anode and which is the cathode, a simple ohm meter test may be performed. However, you must determine the polarity of the ohm meter leads. You will learn how to do that in this lab exercise, and we've done that in the Learning Hub, so I'm not concerned there. Okay, so procedure 1, it says wire the circuit as shown in figure 1. For now, guess the polarity of the diode. So what I've done is I've wired it as per the diagram in your lab. I will just now pan the camera down if I can here to our lab bench. Okay, so what I've got over here is I've got, actually I guess I could raise it up just a little bit so you can see. On this side we've got a 600 ohm resistor. It's series connected with a diode circuit. Okay, now this diode has a protective fuse in it in order to inhibit the amount of current, in order to make sure that we don't blow the diodes up if we connected things up to the wrong voltages. I've got a DC ammeter, digital ammeter connected up in series, as the lab actually asked for an analog one, but the analog ones are hard to pick up on the camera. And then I've also got a fluke meter over here, and that is parallel with the source in order to give you guys a visual on what voltage is being output. Okay, so I'm just going to sort of pan down a little bit here. Whoops, sorry for the jerky noise or movement there. Okay, and maybe shift it over a little bit so we can get the whole thing in view. I'm now going to energize the circuit, and the purpose of this is to see if there's any current flowing. All right, so I power this up, and they asked us to energize it to 100 volts. So you can see the voltage over here. I'm at 38, I'm at 60, 75. It shows the squeaky power supply here. Whoop, 104, I'm a little over. There's pretty close to 100. It's fluctuating up and down a teeny bit. And you can see that we've got 0.16 amps DC flowing through our circuit. So yes, we do have current flow in that circuit the way it is. Then they ask us to de-energize it, and based on the results in step 3, indicate which terminal on the diode board is the anode and which is the cathode. So if we looked and focused in a little bit more on the actual diode board itself, sorry for the jerky movement again, you can see that in the way, with reference to the way that I have the circuit connected, what do we have here? We're coming out of this guy here. Hang on, sorry, I've got my negative coming up to my resistor, so then my instantaneous positive is coming out. And this is going to be an instantaneous negative on that side. This will be an instantaneous positive up here coming up to my meter, and then out of my meter to my true positive, which is over here. Okay, so I would state this guy here, this bottom lead, as an instantaneous negative. So if that's the negative, I would label this end the cathode, and then this part up here the anode. All right. So the red terminal I'm going to label a negative, and the black terminal I'm going to label the positive. Okay, and then they ask us to reverse the supply polarity, which I'm going to do. Okay, and in doing so I have to flip around my meter leads here, otherwise you're going to get some negative values. Okay. And the purpose of this, once we flip that polarity around, we now have hopefully reverse biased this diode. Okay, and in doing so, you would probably see that we shouldn't get any current flow here at all. So I'm just going to zoom out a little bit. I'm going to turn that back down. I'm going to power up, okay, and I'm going to energize the circuit. You can see that I'm at 21 volts. I have no current flow yet. I'm at 45 volts, still no current flow. I'm at 78 volts, 85 volts. I'm at 95, 96, 97, 100, a little over 100, and I have no current flow. Okay? Is there any current flow? That'd be a no. Then they ask us to de-energize the circuit. Okay? What I'm going to do is I'm going to skip to the next situation here. Now I'm all the way up to step 17 of the lab. Okay? I'm going to go into DC volts. Okay, I'm going to crank this guy down a little bit because they ask us to take a measurement at 75 volts, and I've got it connected up in reverse bias still. So remember, a diode acts like an open switch in a circuit. So if I measure the voltage across the diode utilizing this meter here, I'm just going to see if I can get this so that it's a little bit more shown on scale. Okay, so I've got 75 volts as my source here. I'm in DC volts on this guy, and if we have no current flow in this, then I should see purely the 75 volts across that diode, which I do. Okay, and if I increase this to the, what's the next one? They want 100. We're going to see the same voltage there. Okay, and then if I increase it all the way up to 125, which is what they're 120. Okay, we're still sitting at an open switch circuit here, so full voltage drop across the open diode, okay, because that's just measuring the potential. 0 volts up at the resistor itself, okay. Now if I dial that back down, power that down, I'm going to flip my polarity around again to how it was originally. Okay. And what you're going to see here, regardless of the voltage, is if this is now in forward bias, okay, so I'm just going to flip these guys around. If this is a silicon-based diode, we should see this guy read roughly 0.7 volts once we achieve that barrier potential at the source here, and we're going to have current flow. Okay, so we energize. Whoops, I've got my polarities opposite here on that guy. My apologies. So we're at 0.2 volts, no current flow. 0.5 volts, no current flow. And then we're going to get 0.6, no current flow yet, or just a little bit maybe. Okay, hit 0.7. There's 0.7. And now we're at 0.06 amps of current flow through. And we're at 45, 49 volts here. 80 volts, and this is maintaining that roughly 0.7 drop across it. Okay, it's fluctuated up a little bit. And remember, diodes have a bit of a tolerance, okay? And 0.16 amps of current. Okay, so anything less than our 0.7 volts is a source, and this is blocking, okay, open switch until we achieve that, and then it's going to start conducting and allowing current to flow. Okay, so that's roughly 6.1. I know we kind of bumped around a little bit in it, but the purpose of the lab was to sort of demonstrate what we've learned in the classroom. So, see you in the Learning Hub.